Okay, so initially, what is happening? Electrode 1 and 3, this will give supply, okay, and the potential which is developed across these two electrodes, this will help to energize this mercury, and this mercury will emit the ultraviolet radiations. When this ultraviolet radiation will strike the inner coating of this outer glass bulb, which is the fluorescent coating, phosphorus coating, okay, so this will emit light, and it will emit light of bluish color, okay, some bluish white. Mercury vapor lamp, it is basically used for street light purpose, mostly used for the street light purpose. जो भी street light में देखते हो, okay, वो हमारा मरकरी वेपर लैम्प जो कि ब्लूइश व्हाइट कलर हमारा प्रोड्यूस करता है. One more thing is to be noted here that this mercury vapor lamp takes around 5 to 6 minute time to come to glow with full intensity. Okay. अपने पूरे इंटेंसिटी के साथ ग्लो करने के लिए इसको अप्रॉक्स 5-6 मिनट का समय लगता है. इनिशियली अगर हम लोग इलेक्ट्रोड 1 और 2 के बीच में अगर हम लोग सप्लाई देते तब क्या होता, ये एक क्वेश्चन है. Why we are giving supply to this electrode 1 and 3 at the time of starting? Why not across 1 and 2? Okay. Because if we give the supply across these two electrodes 1 and 2, then it is not able to produce a sufficient voltage across the electrodes, okay, which are able to excite this mercury. Okay. And if mercury will not get a sufficient amount of energy, okay, if the potential difference will not develop across this mercury, a sufficient potential difference, then this will not emit the ultraviolet radiation. A certain amount of certain potential difference is required, okay, inside this glass. So that is why this mercury is kept basically very near to this electrode 1 and 3. Okay. And we are giving supply across this electrode 1 and 3. Okay. So that a sufficient potential difference will develop since both electrodes are very near to each other, and that will help to energize this mercury, and then it will develop the ultraviolet radiations, and the remaining things will happen. Okay, so that is the reason why we are supplying across 1 and 3 at the time of start. So this was the construction and the working of this mercury vapor lamp. Okay, the efficiency of this lamp is around 40 lumens per watt. Okay, and it takes 5 to 6 minutes to glow with full intensity. Okay. Basically, it is used for outdoor lighting, especially for the street lights. Okay. So this was about mercury vapor lamp. अगर इसमें कुछ क्वेश्चन पूछना है तो पूछो. Otherwise, I will move to sodium vapor lamp. Any question related to mercury vapor lamp? Any question? Okay, I think it's clear to all of you. Okay, no issue. Moving to sodium vapor lamp. सोडियम वेपर लैम्प जो है इसका हम लोग यूज कहाँ करते हैं, पहले ये हम लोग समझ लें, ठीक है? तब शायद इसको समझना और भी ज्यादा इजी होगा, इसका कंस्ट्रक्शन को। सोडियम वेपर लैम्प का हम लोग स्ट्रीट यूज करते हैं वहाँ स्ट्रीट लाइट में ही, ठीक है? जो हमारा स्ट्रीट लाइट होता है जो कि येलोइश कलर प्रोड्यूस करता है, ठीक है? वो बेसिकली सोडियम वेपर लैम्प है, ठीक है? जहाँ कहीं भी देखते हो येलो कलर का जो लाइट प्रोड्यूस करता है स्ट्रीट लैम्प, दैट इज बेसिकली द सोडियम वेपर लैम्प. And one more thing is very important regarding this is sodium vapor lamp is normally kept horizontal when we are using. Okay, it is kept horizontal. इसलिए कभी देखे होगा सोडियम वेपर लैंप जो भी स्ट्रीट लाइट में यूज करते हैं हॉरिजेंटली उसको हम लोग कनेक्ट करके रखते हैं मोस्टली, क्योंकि जो मरकरी होता है ना इसके अंदर, यहाँ भी सॉरी मरकरी सोडियम, तो वो एक हमारा एक पोजीशन पे मेंटेन रहे, अदरवाइज इसको वर्टिकली यूज करेंगे तो वो एक किसी एक एंड पर ही हमारा अवेलेबल रहेगा, ठीक है? देखते हैं उसको भी, पहले इसका कंस्ट्रक्शन को देखते हैं और सोडियम वेपर लैम्प कंस्ट्रक्शन इसका क्या है। यहाँ भी सिमिलरली दो ग्लास ट्यूब है, एक इनर ग्लास ट्यूब, दिस वन inside this metallic sodium is present and this is the outer glass tube. Okay, so it is U shape construction, U shape का construction है. So inside this metallic sodium is present and these are the two electrodes. Okay, this is cathode and this one is acting as anode. Okay. And we are using a small transformer here. Okay. Why we need this transformer? Because in order to produce a sufficient heat so that this metallic sodium will vaporize and it will emit light, we need a sufficient voltage. So we are using a small transformer here so that if we give a 220 230 volt AC supply, then this transformer will step up this 230 volt AC supply up to around 450 480 volt. Okay, as per our requirement, it will step up the voltage up to around 480 volt. So why we need to step up? Just to provide a sufficient heat to this inner glass tube, okay, so that this metallic sodium will evaporate, okay, and during this evaporation this will emit light, okay? So the light is produced inside this inner glass tube and this will emit in between this outer glass tube and the inner glass tube. There is vacuum, okay? In between both the glass tube this vacuum is present. What is the purpose of providing the vacuum between these two glass tube? To minimize the heat losses, okay? So whatever heat will be there, in order to minimize the losses, we are providing the vacuum, okay, between both the glass tubes, okay? So the light which is generated inside this glass tube, this will emit through this outer glass tube and it will illuminate the surroundings. So it is very frequently used in street lighting And just like the mercury vapor lamp, sodium vapor lamp is also taking some time to glow with full intensity. Okay, it is also taking approx 5 minute time to glow with full intensity. Okay, so this is a very simple construction and the working principle about this sodium vapor lamp. Okay. Its efficiency is around 50 lumens per watt, higher than the mercury vapor lamp. So it is producing more light. If we talk about the same rating of the mercury vapor lamp and sodium vapor lamp, then the sodium vapor lamp will illuminate more light compared to the mercury vapor lamp. Okay. So this was all about the different types of the lighting equipments we are using. Okay. Incandescent bulb, fluorescent bulb, CFL, LED, mercury vapor lamp, sodium vapor lamp. 6 different type of the lighting equipments we are using very frequently in the domestic, commercial, industrial purpose. Okay. So if I will ask from any one of you that based on this parameter, what are the differences between all these type of the lighting equipments, then I think you should able to know, you should able to answer. Okay, so what are the difference? If I ask that uh, which lighting equipment has more efficiency, okay, or what are the what is the efficiency of different lighting schemes I'm using. Okay, so like this we can compare on different parameters. Okay, for example, you can see this one. This column gives the different parameters on which we are comparing the different lighting equipments. Okay. I have mentioned here only 4. Okay. You can also add 2 more, CFL and LED. So if we talk about the starting time, then the incandescent bulb is instantly start. As soon as we will give supply, incandescent bulb will start. Okay, it will start to emit light. Fluorescent lamp, it will take fraction of seconds. Mercury vapor lamp will take 5 to 6 minutes in order to illuminate. Okay, sodium vapor lamp will also take 5 to 6 minutes. Like this, you can compare the different lighting equipments on a particular parameter. Okay. एक और देखते हैं हम लोग इसमें किसी पैरामीटर को. Color of the light, it is very near the natural light in case of the incandescent lamp. In case of the fluorescent lamp, color varies according to the coating. Obviously, हम लोग किस तरह का coating use करते हैं inner glass tube में, उसके according हमारा कलर वेरी कर सकता है. अगर फॉस्फोरस का यूज कर रहे हैं तो ब्लूइश व्हाइट कलर का हमारा लाइट प्रोड्यूस करता है. इन केस ऑफ द मरकरी, कलर इज वेरी pleasing and color distortion is high. It is also bluish white color मरकरी वेपर लैंप में भी. ठीक है, दोनों का कंस्ट्रक्शन थोड़ा सा वेरी करता है, प्रिंसिपल भी ऑलमोस्ट सेम ही है. So both are producing bluish white color and the sodium vapor lamp is producing yellowish color. Okay. एफिशिएंसी की अगर बात करें तो एफिशिएंसी इनकैंडेसेंट के केस में 12 लुमेन्स पर वॉट, इन केस ऑफ दिस fluorescent tube efficiency is 40 lumens per watt. In case of the mercury vapor lamp, it is 40 lumens per watt, almost same. And in case of the sodium vapor lamp, it is around 50, 60 or up to 70 lumens per watt also. Okay. Average life is 1000, 4000, 3000, 3000 working hours. So in this way, you can compare the different lighting equipments on different parameters. Okay. Okay. The next topic under this module is the type of the lighting scheme. Okay. So basically, the different types of the lighting scheme is defined based on the theory or based on the you can say the assumption that whenever a light source is producing light, okay, it is illuminating, then all the lumens is not reached up to the working plane. Okay. Some lumens will reach up to the working plane and some will go into the surroundings, or sometimes some lumens will reach to the working plane through reflection. Okay. अगर किसी बल्ब को ऑन करते हैं किसी कमरे में, तो अगर वर्किंग प्लेन हमारा एक टेबल रखा हुआ है तो वहां पर लाइट या तो डायरेक्ट आ सकता है या तो रिफ्लेक्ट होकर के वॉल्स के थ्रू उस वर्किंग प्लेन पर आएगा, और it may be the combination of the direct or the reflected light. Okay. So based on this assumption, the different types of the lighting schemes are: the first one is direct lighting. Direct lighting कहने का क्या मतलब है हमारा? In this case, the light from the source is shown directly over the surface to be illuminated. Okay. अगर बल्ब से लाइट डायरेक्टली हमारा सरफेस पर आ रहा है, ठीक है, सो दैट इज अ केस ऑफ डायरेक्ट लाइटिंग. ओके. It is such type of the lighting scheme is particularly used in industry for high intensity of light. Obviously, अगर डायरेक्ट लाइटिंग है, डायरेक्टली लाइट हमारा इस वर्किंग प्लेन पर अगर अवेलेबल हो रहा है लाइट ऑन करने पर, दैट मीन्स द इंटेंसिटी इज मोर, इंटेंसिटी इज हाई. Okay. So this type of the lighting scheme we are using in industry, okay, where we require the high intensity of the light. The second one is indirect lighting. Indirect lighting क्या है? In this case, no light reaches directly from the source on the surface to be illuminated. Just reverse of the direct lighting. Direct lighting के केस में हमारा सारा का सारा जो भी लाइट आ रहा था वो डायरेक्टली वर्किंग प्लेन में आ रहा था. But in case of the indirect lighting, no light reaches directly. जो भी लाइट आ रहा है थ्रू रिफ्लेक्शन. लाइट ऑन किए, वॉल्स में रिफ्लेक्ट हुआ, वॉल्स के रिफ्लेक्शन के थ्रू वो हमारे टेबल तक लाइट पहुंच रहा है, डायरेक्टली लाइट नहीं आ रहा है. अगर ऐसा सिचुएशन है तो दैट कम्स अंडर द कैटेगरी ऑफ इनडायरेक्ट लाइटिंग. तो we may use a light which is focusing towards the ceiling of a room. Okay. Then in that case, the light will reach to the table through reflections. Okay. सीलिंग के पास अगर हम लोग उसको फोकस करके रखें उसका काफी नजदीक, तो क्या होगा, लाइट डायरेक्टली तो हमारे नहीं आएगा टेबल के पास, वो रिफ्लेक्ट होकर के ही आएगा. okay. अगर इस तरह का लाइटिंग अरेंजमेंट हम लोग करते हैं तो that will we will call the indirect lighting scheme. Okay. बेसिकली इस तरह का लाइटिंग स्कीम देखने के लिए हम लोगों को कहाँ मिलेगा? हॉल, क्लब, रेस्टोरेंट, okay, where we are not getting the light directly from the light source. We are getting in the reflected way. Clear? The difference between the direct and the indirect lighting. Next one is semi-direct lighting. If the percentage, if we talk about the percentage, if more than 60% of the light will reach to the surface directly, okay, so that comes under the category of semi-direct lighting. Okay? If we switch on a bulb and more than the 60% of the light will reach to the working plane directly, and the rest 40% will reach through reflections, then that type of the lighting scheme will come under the category of semi-direct lighting. Okay. And if the situation is reverse, it means if more than 60% of the light will come after reflection to the working plane and less than 40% will come directly to the working plane, then that type of the lighting scheme will called the semi-indirect lighting scheme. Okay. So these are the main 4 types of the lighting schemes: direct lighting, indirect lighting, semi-direct lighting, and semi-indirect lighting. Very simple definitions. Okay. Apart from these 4 types, we are also using 2 different types of the lighting scheme. Okay. You will find in the literature these 2 types of the lighting scheme also. The first one is the local lighting and the second one is general lighting. Okay. What is the meaning of this local lighting? If the light is confined to illuminate a particular object, it is called the local lighting. अगर किसी स्पेसिफिक ऑब्जेक्ट को इल्यूमिनेट करना है, उसी को फोकस करके अगर हम लोग किसी लाइट को हम लोग डिजाइन कर रहे हैं या उस लाइट को वहां पर हम लोग इंस्टॉल कर रहे हैं, so that comes under the category of local lighting. Okay, like a table lamp. ठीक है, table lamp is very much focused to the book which is kept on the table. Okay. So you may call it as a local lighting. Okay. General lighting. What is the meaning of this general lighting? It means this lighting scheme is designed for the general purpose. Okay. अगर कोई एक बड़ा हॉल है, okay, और उसके अंदर में डिफरेंट लाइट सोर्सेस अवेलेबल है, बट क्या हो रहा है कि हर एक लाइट सोर्स का अपना एक एरिया है, जिस पर्टिकुलर एरिया को वो इल्यूमिनेट कर रहा है, बट इन बिटवीन those areas there are some dark patches or there are some area which is getting a very less light. Okay, वहां पर लाइट का इंटेंसिटी कंपेयर टू द अदर एरिया वो कम है. अगर वैसे सिचुएशन को अगर इमेजिन करो, ठीक है, तो such type of the lighting scheme is called the general lighting. That means the lighting scheme is not proper, it is very general. Okay, कहीं कहीं भी एक एक हम लोग लाइट सोर्स को इंस्टॉल कर दिए है, बट इक्वल इल्यूमिनेशन हर एक एरिया में नहीं मिल रहा है. अनइक्वल डिस्ट्रीब्यूशन ऑफ द इल्यूमिनेशन इन द कंप्लीट हॉल. ठीक है, अगर इस तरह का हमारा सिचुएशन है, सो दैट इज कम्स अंडर द कैटेगरी ऑफ जनरल लाइटिंग. ओके, सो दीज आर द different types of the lighting schemes. Any question related to this lighting scheme? very simple definition. Huh? I don't think that there will be much more difficulty to understand these lighting schemes. Okay. That you are also seeing in daily life. Okay. डे टू डे लाइफ में इस तरह के बहुत सारे एग्जांपल्स देखते हैं. So that is just a part of the different lighting schemes. Okay. So what are the different methods we are using for calculation of this light? Okay. कितने lumens required है किसी एक पर्टिकुलर ऑब्जेक्ट को इल्यूमिनेट करने के लिए? okay. किसी एक हॉल में कितने लाइट सोर्स का इंस्टॉल करने की जरूरत है so that per square area this much illumination will be available. तो अगर इस तरह के चीजों को अगर कैलकुलेट करना हो so we can use one method that is called the light flux method. Okay. लाइट फ्लक्स मेथड क्या है हमारा? बेसिकली यहाँ पर हम लोग क्या करते हैं, अगर हम लोगों को निकालना है कि ल्यूमेंस विच इज रिसीव्ड ऑन द वर्किंग प्लेन. ठीक है, अगर कुछ लाइट सोर्सेस किसी हॉल में अगर 10 सपोज 10 लाइट सोर्स है, उस सबको अगर हम लोग ऑन करते हैं तो क्या वो एक पर्टिकुलर वैल्यू ऑफ लुमेंस विच इज रिक्वायर्ड टू रीच एट द वर्किंग प्लेन, whether that 10 light bulbs are able to produce that much lumens. Okay. Or in another way you can think that in a hall an object is kept and this much lumens is required for that object. Okay. So how many number of bulbs is required to install in that hall so that this much lumens will reach to that particular object. Okay. अगर इस तरह से हम लोग को कैलकुलेट करना हो, so we can calculate with the help of this expression. Okay. This simple equation. Equation कुछ नहीं है, हम लोग जो पहले न्यूमेरिकल्स देख चुके हैं बेसिकली वही है. ठीक है, मेथड इज सेम, द प्रोसेस इज सेम टू कैलकुलेट द lumens received on the working plane. Okay, that is equal to number of lamps into wattage of each lamp multiplied with the efficiency of each lamp, and that is also multiplied with some factors. What are those factors? The coefficient of utilization into maintenance factor divided by the depreciation factor. Okay. So if the number of lamp is 10 and the wattage of each lamp is suppose 40 watt, so how much it will be? 10 into 40, it is 400 into efficiency of each lamp. Efficiency is suppose again 40 lumens per watt. Okay, it is incandescent, sorry, it is a fluorescent tube. Okay, so it is 10 into 40 into 40. So how much this will be? 400 into 40, 16,000. So 16,000 multiplied with the coefficient of utilization, maintenance factor, and the depreciation factor. If we know these factors, okay, then we can find out the lumens which is received on the working plane. Okay, so in this way we can calculate the lumens which is received on the working plane, or the number of the lighting sources which is required to provide a sufficient light on the working plane. Okay, so this is one method. Another method we have already seen, the inverse square law method. Okay, एक न्यूमेरिकल हम लोग देखे थे कि दो लाइट सोर्स थे, तो एक लाइट सोर्स के नीचे कितना ल्यूमेंस आ रहा है. okay, तो दोनों लाइट सोर्सेस का इफेक्ट क्या था, तो ये सारे हम लोग देख चुके एक प्रोसेस कैसे हम लोग कैलकुलेट करते हैं, तो वो एक इनवर्स स्क्वायर लॉ मेथड था. ठीक है, तो ये दो मेन मेथड है हमारा लाइटिंग कैलकुलेशन के लिए। okay? एक न्यूमेरिकल भी हम लोग देख लेते हैं इससे रिलेटेड, so that we can understand this steps in very clear manner. Okay. ये एक न्यूमेरिकल है, हम लोग देखते हैं। क्वेश्चन क्या है? An illumination of 30 lux is to be provided in a classroom of area 20 meter into 10 meter with 40 watt fluorescent lamp. 40 वाट का फ्लोरेसेंट लैंप है। तो हम लोगों को एक क्लासरूम है जिसका कि एरिया 20 मीटर इंटू 10 मीटर है, उसमें 40 वाट के फ्लोरेसेंट लैंप को इंस्टॉल करना है। उसको इस तरह से इंस्टॉल करना है कि 300 लक्स, दिस मच इल्यूमिनेशन is available in the classroom. Okay. Determine the number of layout of the lamp in the lighting installation. So कितने फ्लोरेसेंट लैंप को हम लोगों को इंस्टॉल करना पड़ेगा और वो फ्लोरेसेंट लैंप को कहां कहां इंस्टॉल करना पड़ेगा, ठीक है, डिस्टेंस क्या होगा, ये हम लोगों को निकालना है। क्वेश्चन इज क्लियर? We have to find out the number of fluorescent lamp which is to be installed in a classroom of 20 meter into 10 meter so that an illumination of 300 lux will be provided. Okay. Fluorescent lamp का rating क्या है? 40 watt and the coefficient of utilization is given 0.5 and the depreciation factor is 0.7 is also given. Okay. So let us see how we will calculate the number of lamp. Area is given 20 into 10, that is 200 meter square. Okay. Illumination is given 300 lux and the wattage of the fluorescent lamp is given 40 watt. So flux required is illumination into area into A, that is equal to 60,000 lumens. So 60,000 lumens is will be available. Okay. So flux which is necessary to be produced, कितना flux produce करना पड़ेगा? Since the coefficient of utilization and the depreciation factor is given, so divide this 60,000 from this coefficient of utilization and depreciation factor. Okay. And if we talk about the wattage, okay, then wattage of the lamp will be how much? This total flux divided by this efficiency. Okay. So it is 4,000 watt. Efficiency is what? Output by input. Efficiency is given 40 lumens per watt. So it is output by input. Output is how much? Output is this 60,000, which is the total lumens divided by input. So this will be the input, 4,000 watt. So 4,000 watt is the input. That means what should be the number of bulbs so that the total input will be 4,000 watt. We know that the rating of one bulb, that is 40 watts. So total number of bulbs will be 4,000 divided by 40 equal to 100. So 100 bulb we need to install in this classroom of area 20 meter into 10 meter so that an illumination of 300 lux will be available. Okay. So the second part of this question is how we will install or where we will install. Okay. कहाँ कहाँ इसको इंस्टॉल करना पड़ेगा ये 100 bulbs को. Okay. So if we consider a situation that is not given in the question, okay, but if we assume that this fluorescent lamp is a combination of two lamps, okay, one lamp is a combination of two, ट्यूबलाइट देखते हो ना कि एक साथ दो ट्यूबलाइट को हम लोग इंस्टॉल करते हैं, उसको हैंग करते हैं, ठीक है। अगर उस तरह का हमारा ये है कंस्ट्रक्शन है, ठीक है, उस तरह का अगर हमारा लाइटिंग स्कीम है जिसको कि डिजाइन किया गया है, सो नंबर ऑफ पेयर कितने होंगे? इट विल बी 100 डिवाइडेड बाई 2, क्योंकि एक में हमारा दो फ्लोरेसेंट लैंप है, सो इट इज 100 बाई 2, दैट इज 50. And how we will install these 50 lamps? So it is installed like this, okay, 10 bulbs in a row, so there are 5 different row, so that 50 pair of lamp will be accommodated. And what should be the distance between each lamp? It is 2 meter horizontally and 1 meter vertically, so that it will cover the whole area, 20 meter into 10 meter, equally distributed. You can equally distribute in this manner, okay. So like this